Hi, welcome to this video. We'll talk about nominal and effective discount rates. We've already talked about nominal and effective interest rates in Module 1, Section 4, and this is a very similar situation. We're just talking about discount rates instead of interest rates now. Let me go back and remind you quickly of the interest rate example that we had. We had this problem with Bob. He deposits $1,000 into an account which credits interest using an interest rate of 8% compounded quarterly, and the question was how much will Bob have in the account after 6 months. So that was this second line here. We have that rate is a nominal rate. It doesn't say it, but I know it's a nominal rate because I see the word compounded following the rate. So this is a nominal rate compounded quarterly. Quarterly is 4 times a year. So the notation for this was an I upper 4. I upper 4 was 0.08. And the first thing we do with that I upper 4 is divide it by 4 to get what's then called the quarterly effective interest rate. Once I have the quarterly effective interest rate, I know the quarterly accumulation factor is 1 plus that. And then the accumulation function is A of t equals 1 plus I, 1 plus this quarterly effective interest rate raised to the t power. In this case, it would be 1.02 to the t. T is measured in quarters. I'm looking at how much will Bob have after 6 months. 6 months is equivalent to 2 quarters. And so I would plug in a 2 for T, and I would accumulate 1,000 by multiplying by 1.02 to the second power to get the amount after 6 months or after 2 quarters. Okay, so now let's tweak it a little bit. Look at the second line there. It says using an interest rate of 8% compounded quarterly. Now we're going to do a discount rate example. Same problem, basically the same problem. The second line says using a discount rate of 8% compounded quarterly. Okay, so that's the key word, the discount rate. So now it's you probably know what the notation is without me telling you. The interest rate, the nominal interest rate notation was an I upper 4 in this case, but this is a discount rate, so I'm going to use a D upper 4. D upper 4 is the 0.08. Again, the first thing I'm going to do with that is divide it by 4, and then that's going to give me what's called the quarterly effective discount rate, so the QEDR. Once I have the quarterly effective discount rate, I know what the accumulation function is now, because the accumulation function using compound discount, when we're compounding using a compound discount context, the accumulation function is 1 minus d raised to the minus t, and with a d of 0.02, I just get a 0.98 to the minus t power. Again, just as before, I'm looking at a 6-month accumulation. 6 months is 2 quarters, so I'll plug in a 2 for t, and I'll see that the accumulated value of that 1,000 is 1,000 times 0.98 to the minus 2, and going through the arithmetic, you'll see that that's $1,041.23. So again, this is a discount rate compounded quarterly. I just want to remind you of some synonyms. If the problem said converted quarterly, that's just a synonym for compounded quarterly. I get the exact same solution. It might say payable quarterly. Those are just synonyms. You know, it could say compounded, converted, or payable. All means the same thing. You're going to do the problem the same way. You're most likely to see it as a compounded quarterly problem, 8%, and then following that compounded tells me that's a nominal rate. Now, what if I change that quarterly? So now I'm going to change the word quarterly to another period of time, say semi-annually. So what if this was a semi-annually compounded discount rate? I'm sure you know what I'm going to do. Semi-annually means 2 times a year, so I'm going to use an upper 2 notation, and the solution would look like this. I would have a D upper 2. The 0.08 would be represented by a D upper 2, and then I take the D upper 2 and I divide by 2 to get a 0.04, and that would be called then the semi-annual effective discount rate. And then the problem proceeds as before. The accumulation function is 1 minus that D, or 1 minus 0.04, 0.96 raised to the negative t power. This time, 6 months is the t, though, is measured in semi-annual periods, and since 6 months is exactly 1 semi-annual period, I'm plugging in a 1 for t, and I would get that the accumulated value is 1,000 times 0.96 to the minus 1, and you can see on the screen that's $1,041.67 would be that accumulated value. Okay, so the summary, this is very similar to what we did before with nominal interest rates. When you have a nominal discount rate compounded M times per year. We denote that with a D upper M. Keep in mind it's always an annual rate. And then we divide that annual rate by the number of compounding periods per year. In fact, so in other words, divide that annual rate by M, D upper M over M will give us the periodic effective discount rate. That's that EDR. Same comment as before with respect to dividing things here. You're never going to take a D upper 2 and divide it by anything other than 2. So D upper 2 will be divided by 2, D upper 4 will be divided by 4, and so forth. And that's similar to what we talked about with nominal interest rates. Okay, so I will see you in the next video.